How they are working basically. It is basically reacting with the cementitious system, and that is basically giving a temporary effect. So wherever we are having difficulty in getting a workable concrete, workable in the sense when your concrete you have prepared, it has to mix properly, we are able to transport it, then we can place it with manually pumping or any other means which is available at site, depend upon the application. In the sense that we need certain concrete for pile concrete, where high workable concrete. Then we have columns where we can medium workable concrete, and then we have slab also. So keeping if the grade is same, but workability requirements are different. We need more flow or more slump, or we require any stiff concrete. So depending upon your requirement, we can choose the admixture to get more flow in the concrete or whatever workability you need. And all these admixtures basically working reacting with cement and getting more flow without adding more water, and that effect remains for certain time, maybe half an hour, 1 hour, 2 hours, 3 hours, whatever time you decide. You can select accordingly the admixture, and then you can use that particular proportions, particular mix proportion, percentage dosage you have to use, and then we'll get the condition. But whenever there is a change in ambient conditions, definitely dosage of admixture also change. In hot season, you may require more admixture dose. In winter, where our temperature is cool, we require a lower dosage. So that one has to understand, and accordingly you have to select. In market, a lot of admixtures are available, a lot of manufacturers are there. Ultimately, we have to decide which is the best one for us and which is the best economic also. So how they work basically it, when you add into the cement, and this is one thing we have to remember, you do not add any admixture on dry cement. It will not work. So whenever you are adding any admixture in concrete, the cement has to be weighted. You have to add cement, then water partly, maybe about 80-90% water we can add, makes it a slurry or wet concrete, and then you can add the admixture. Then only it will give a effect. So this sequence one has to remember very carefully. When you are adding any admixture has to be added once you have mixed the concrete with partly water, maybe 80-90% water, and then you can add admixture to get more effect and minimum consumption of admixture. Some people or some site, maybe some batching plant, they don't have the proper arrangement for dispensing the admixture dosing systems, so they add directly into the water itself because of mixing is better. But what is happening is, if you add into the water, whatever admixture is there along with water, most of the time when you are using, your aggregates are in dry stage, so they absorb a lot of water. So whenever you are adding admixture along with added into the mixing water, that admixture also absorbed by the aggregates, and you may not get same image effect of the admixture once you add it separately after adding water. So that one has to remember very carefully and get the best uh, performance of particular admixture is to add at the end. at the end. So sequence one has to see very carefully, because batching plant there is the facility to change the sequence of material batching and mixing also. When you visit RMC, you must see when they are adding this, and the performance can be judged properly. So how they're working is basically when you add admixture into the cement paste or wet cement, is each particle of cement coated with your admixture and make a bunch like this. See, these are the your cement grains. So inside that, a lot of water is trapped. Now, when you add admixture, the film develop on the each grain of cement, creating a positive charge. Now, this, as you know, same valency of the charge will repulse. Opposite valency will be attract. So once it is repulsed, whatever trapped water within the particles is released. So without any adding more water, you get concrete seems to be require feel it is a more flowable. Suppose you have got 50 mm slump, add admixture, you may get 100 150 mm slump without adding more water. So this is the basic phenomena how they work. There's a different phenomena are there. This is one of the technique they use for using admixture. They are all surfactants and they are creating charge on each particles, and each particle similar charge they repulse and get the entrapped water out of the for the system. When that additional water available for the system, you get more workable mix on the same proportions. That is the how it works, the admixtures. These are basically combined dispersion and fluidification properties of water reducer and supervisor in the concrete. What we are right now we are seeing. These are interaction of two kinds. One is the steric repulsion on plasticizer absorption. Due to the plasticizing, they create a charge and get repulsion. And then electrostatic repulsion. Right now, whatever you have seen is a electrostatic repulsion. So this is the type how they works. We'll not go into detail about the chemistry of this, but that is a totally different subject. One has to do something, a lot of work on it. They can go into this because admixture has got huge potential in the concrete. Because whatever concrete today we are using, around 90%, 95% concrete we are using admixtures, various types of admixtures. Now, certain admixture also contain a lot of polymers. So that also adds to give more strength in the concrete also. Because some are only pure water reducer, some of the combination of polymer and water reduction capacity. So you get more strength also. Some people add certain certain materials which also reduce the porosity of the concrete. So they act as a reducing the permeability of the concrete. Some people add also sinkage reducing admixture in the normal admixture also. So you get additional properties. So we have got value added product from the same one product. So depend upon your application and cost estimation definitely. Now you have to see the cost because cost is very important in your all the projects. So that one has to see and accordingly you select the your admixture. This is how it works basically. See charges. This is cement grains, electrostatic repulsion, and sometimes you get also polymer. Now we'll just see small video where they will show how it is really seen the your working their admixtures. This is how it works. So this is how it works. Basically, you can see the chains, longer chain. Maximum chain will give more retention time. Means nowadays, you have concrete is coming from RMC plant. They have to travel 1 hour, 2 hours, sometimes 3 hours. Then you have to also require certain time at the project site for placing and then finishing, compaction, other issue. So overall time you may need around 3 hours or 4 hours. How to retain that mix, such a high binder content, such a high grade concrete. So that is possible with the fourth generation admixture, the PC admixture, polycarboxylate ether. The derivatives of that is available today in the market to get this admixture. See another video. So this is how the admixtures are working. One is to whenever you are selecting admixture, this phenomena is very important to understand, and accordingly we have to select the type of admixture, number of dosage, how much you have to add, and whole thing depend upon the how much time you need for working. So right from mixing, once you add your water into the mixed proportion, that you start at 0 time, and then to the finishing. Maybe you need 3 hours, 4 hours, 5 hours. Today, it's possible to design or get a admixture which is required for our purpose. So whenever there is a specific requirement, we have to discuss with admixture manufacturer, not with the dealer. You have to directly talk to the manufacturer, ask him to give your requirements and get tailor-made admixture, because a lot of varieties are available today, and depend upon your other ingredients like cement is there, fly ash is there, or GGBS is there, microsilica is there, or other microfine cements are there. And now another one component is also is playing major role is your crust stone sand. Though we are saying that crust stone sand has not is a inert material, not reacting with anything. It act as a filler. But when they are producing this sand at the quarry end, a lot of clay material or overburden clay may mix with the fine aggregate. Now this clay is responsible for the response to your admixtures. Maybe it is compatible with your cement, but sometimes your sand contain lot of clay which is coming from the overburden soil, maybe get the affected your performance of admixture. This point you have to remember very carefully, and that is only possible if you do number of tests. I'll show how to go about that, but this is one of the observation that admixture may give different behavior or performance once sand contain lot of clay. Secondly, your fly ash. Whenever there is a fly ash you are using, it may come sometimes there is a carbonate, carbon, because they are coming from thermal power stations. Is a burned particularly coal, and certain amount of carbon, unburned carbon may be available in the fly ash. Certain percentage allowed by the IS, but if the percentage goes up, you will find that they are affecting the performance of admixture, because they absorb admixture. So in turn, you may use more admixture with the particular source of fly ash. So when you are using this admixture, these points one has to very carefully remember to check the performance of admixture, because varieties of materials available with you. Even admixtures also, there is a various types are available. One has to select appropriate material for the particular application. So using water reducer, we will discuss this during this lecture ahead also. So compressive strength is increasing because you are not increasing the water content. So whenever you start your mix design, you are stuck up with certain maximum cement content and the water cement ratio. Then you are not able to increase the cement content because of the limitations specified by standards. Then there is the only way that I can reduce my water content. How to reduce? I can use admixture. Now, how much to be reduced? That depend upon which type of admixture you are using. As I said earlier, you get normal plasticizer, super plasticizer, and fourth generation admixture, super plasticizer. So depend upon their water reduction capacity, you can select that and get the more benefit in your concrete. The strength within, without increasing the cement content, I can get more strength. So that is the major advantage of this admixtures today, whatever you are using in most of the concrete. Permeability decreases. Once the permeability is decreases, there is a chloride resistance increases, frost resistance, and increase the sulfate resistance because pollutant will not enter into your concrete. Once the pollutant are not entered, your reinforcement is safe and the your life of the structure can be improved. So one has to remember that the concrete, the life of the structure is depend upon the cover concrete. Right from 20 to 50 cover, that decide the life of your structure. If you make the cover concrete is impermeable, your structure will last for a longer time, required minimum maintenance. Because concrete itself will not corrode. The reinforcement is corroding and then it is damaging their capacity. So one has to remember if I have to make very good structure, I have to make proper cover concrete or impermeable cover concrete near to zero. Increase the resistance to abrasion, other disadvantage. Now there is a set retarding admixtures also available. Sometimes it is a part of super plasticizer. You can add into that and make your own requirement. Set retarding admixtures are very useful in hot weather concreting or whatever we are right now working in Mumbai or our country is also is the temperature is hot. In summer temperature may go up to 40-45 degrees. Now whatever workable concrete we are designed initially, maybe for the normal temperature 25 degree or 30 degree, may not give same performance when the ambient temperature is increased to 40-45 degree. Now to overcome those difficulties, we can use set retarding admixtures. There is a separate set retarding admixtures are available in the market, or we can request manufacturer to blend certain amount of admixture in your super plasticizer and give a particular blend to your requirement. So setting time can be tailor made. I want 6 hours, 8 hours, 10 hours, 24 hours, or even 72 hours. My concrete can I can keep alive. Depend upon your long transport time, placing large foundations where you need more time for processing concrete, and also to avoid construction joint because there is a large pour. You have finished one layer and come to this second layer concreting. It may take 4 hours or 5 hours. If the first layer has already set, then if you put another concrete, there is a cold joint. So avoid that. I can use this set retarders to design my setting time of concrete. So setting time of concrete is very important. At least initial setting time is very important because once the concrete set initially, we cannot vibrate the concrete. We are not supposed to disturb their bond between paste and aggregate. So we can work out depend upon ambient condition, what is the set retarders you want or which type of admixture you want, you can use that. Large foundation, oil well cementing, you must be knowing where for oil rig, when you put a oil well and we have to seal the oil well maybe about 1 kilometer, 2 kilometer below the surface or 5 kilometers below the surface. And at that location also your temperature is also very high. And when you are using cement, one has to delay the initial set. So you use super retarders to get that particular setting time. It's possible today, so one has to work on. Most of the admixture, if you use, as I said, lignosulfonate or sugar or tartaric acids or sodium gluconate salt. These are basically a retarders. Hydrocarboxylic acid also a retarder. So one is for water reduction, one is for keeping your work concrete alive for more time. That one has to carefully remember. Concrete has to work for more time. Initially, you may get very good flow, but by the time it reaches that side, slump has dropped, flow has dropped. It is very difficult to pump. It is very difficult to place or very difficult to compact. So that concrete will nobody will accept. So this will have to design accordingly as per your wish or maybe project requirements, rather project requirements. Delays rate of hydration of hydraulic cements, delays in setting time, initial setting time, and delays in early setting development. So you may not need some certain strength at particular level or particular application. So that one has to carefully select the admixtures. So similarly, it is happening about when there is a high temperature, slump loss, very fast slump loss. So we can add only water at side, that is again reduce this strength content. And if it is hydrated cement paste affected later age, also gives a lower strength. So whenever there is a high concrete temperatures, when you are working for ambient conditions are not favorable, hot weather concreting, then you have to keep concrete cool, applicable to get retarders to be used, or you can cool the mixing water and aggregates. In opposite that, when you are working for cold weather concreting, I have to heat the material. I can use warm water. I can use accelerators. Suppose you are working in Himalayas or Kargil or Ladakh, where temperature is maybe sub-zero level. So there normal concrete will not set at all because hydration will not take place. Then I can go for set accelerators to accelerate the setting time. So there is a special code for this, IS 7861 part 1 and part 2. You can just go through that. Extreme weather conditions. How to work with extreme weather conditions. One is hot weather, one is cold weather. Which is not applicable here in Mumbai or Maharashtra.